Hello and welcome to Math World, the world where difficult mathematics can be a very easy one. So today we are going to speak about a very important theme in mathematics, logarithms, law of logarithms, and we are going to show you how to apply the law of logarithms in different calculations. Firstly, let's bring some facts about logarithms. Logarithms were defined by Scottish scientist John Napier. In the late 16th century, astronomers spent a large part of their working time doing very complex calculations. John Napier discovered the method of simplifying these calculations using logarithms. The method was so effective that it was said that he effectively gave a new life to astronomers by reducing the time required for calculations. Today, it is hard to find a domain of science in which logarithms are not used. So, now, let's understand what is a logarithm. We say that the real number n is the logarithm of a positive number a in base b, where b is more than 0, b is different from 1, if b to power n is equal to a. It is denoted by n equal to log from the three letters of word logarithm, so log in base b of a. From the definition of logarithm, you have to remember the following things. If n is equal to logarithm in base b of a, then a is more than 0, b is more than 0, and b is different from 1. If b to n is equal to a, then n is equal to logarithm in base b of a, and vice versa. If n is equal to logarithm in base b of a, then b to power n is equal to a. For example, 4 to power 3 is equal to 64. It follows that logarithm in base 4 of 64 is equal to 3. Logarithm in base 7 of 49 is not equal to 3, because 7 to power 3 is not equal to 49. In mathematics, there are some special notations from logarithm in different bases. For example, for logarithm in base b of a positive number a, we use the notation log a. Remember, if no base is indicated, we assume it means base 10. Second, for logarithm in base e, where e is approximately 2.71 of a positive number a, we use the notation ln a. Remember, ln a represents the logarithm in base e of a positive number a, and it is called natural logarithm. When working with logarithm, everyone should know some special laws which have to be understandable and be applicable. If a and b are positive numbers and c is more than 0, c different from 1, then logarithm in base c of c is equal to 1. So remember, when you have the logarithm which has the same base and argument, then the answer is 1. Logarithm in base c of 1 is equal to 0, because c to power 0 is equal to 1. Logarithm of a in base c plus logarithm of b in base c is equal to logarithm in base c of a multiplied by b. So if you have the sum of two logarithms which have the same base, then it will be just one logarithm, and the argument will be the multiplication of arguments of the two previous logarithms. Logarithm in base c of a minus logarithm in base c of b is equal to logarithm in base c of a divided by b. C to power logarithm in base c of a is equal to a. Logarithm in base c of a to power alpha is equal to alpha multiplied by logarithm base c of a, where alpha is a real number. Logarithm of a in base c to power alpha, so now the base is raised to some power, then it is equal to 1 over alpha logarithm base c of a, where alpha is a real number but different from 0. Logarithm base c of a is equal to logarithm base b of a divided to logarithm base b of c, where b is more than 0 and b is different from 1. This property is also called in mathematics the change of base rule. From this property, it can be deduced the following property. Logarithm base c of a is equal to 1 of the logarithm in base a of c. Next, let's see how to apply these laws of logarithms in some calculations. First exercise. Write as a single logarithm logarithm base 3 of 20 minus 2 logarithm base 3 of 4. So here, firstly, we will apply this law or this property of logarithm, and we will bring 2 as the exponent to 4. And by using the property that it was mentioned, we will have logarithm base 3 of 20 minus logarithm base 3 of 4 to power 2. It is known that 4 to power 2 is equal to 16, so we get logarithm base 3 of 20 minus logarithm base 3 of 16. Next, by using this property, where we had the difference of two logarithms, but attention, with the same base, we will get just one logarithm and the arguments will be divided. So we get logarithm base 3 of 20 divided by 16, where by simplifications we get the final answer logarithm base 3 of 5 divided by 4. Nice. Next exercise. Logarithm base 4 of 25 minus logarithm base 1/2 of 3. So here we will use a small trick. We see that we have two different bases, base 4 and base 1/2. But the very interesting thing is that the both bases can be represented as 2 raised to some power. So 4 we will write as 2 raised to power 2, and the first logarithm will get the form logarithm base 2 to power 2 of 25 minus the second logarithm will get the form logarithm of 3 in base 2 to power minus 1, because, attention, 1 over 2 is equal to 2 to power minus 1. Next, by applying this property to these two logarithms, because we had the exponent to the base of logarithm, and using the property mentioned here, we will get 1 over 2 multiplied by logarithm in base 2 of 25 plus logarithm base 2 of 3. Your question can be, why the sign minus changed to plus? Because minus multiplied by minus will give us plus. Next, for the first logarithm, we will use the following property, and we will write 1 over 2 as the exponent for 25. And we get the following. Logarithm base 2 of 25 to power 1 over 2 plus logarithm base 2 of 3. Because 25 to power 1 over 2 is equal to the square root of 25, which is 5, we get the following form of the exercise. Logarithm base 2 of 5 plus logarithm base 2 of 3. Next, by using this property, because we have the sum of two logarithms which have the same base, we get logarithm of base 2 of 5 multiplied by 3, which is logarithm base 2 of 15. Nice. Next exercise. 0.5 logarithm base 5 of 16 plus logarithm base the square root of 5 of 1/3. Here, for the first logarithm, Using the property that we can bring the number that is in front of a logarithm as the exponent to the argument, we will get that the first logarithm can be written in the following form. While for the second logarithm, we will use the trick that the square root of a positive number can be written as this number raised to the power 1 over 2. So the exercise takes the following form. Logarithm in base 5 of 16 to the power 0.5 plus logarithm of 1/3 in base 5 to power 1 over 2. Next, for the second logarithm, we see that we can apply this property. And the exercise will give us in this form. Logarithm base 5 of square root of 16, once again, because 16 to the power 0.5 is equal to 16 to the power 1 over 2, which is the square root of 16, plus, next, by the property that was mentioned before, we have 2 multiplied to logarithm in base 5 of 1/3. Next, for the second logarithm, again with the well-known property, we can bring 2 as the exponent to the argument 1/3. And we will get this exercise in final. Logarithm base 5 of 4 plus logarithm base 5 of 1 over 9. Oh, very nice. We have the sum of two logarithms. We have the same base. And by using this property, we can write as a single logarithm, and we will multiply the arguments of the two previous logarithms, and we will get the final answer, logarithm base 5 of 4 over 9. Nice. Next exercise. Find the following, attention, without using a calculator. Logarithm base 81 of 3 minus logarithm in base the square root of 5 of 1 over 5 plus logarithm in base 2.5 of 0.5. So, very interesting exercise. But if you analyze attentively each logarithm, you can see the following connection. In the first logarithm, the base is 81, while the argument is 3. Interesting. What can we do here? Oh, yes. 81 is equal to 3 raised to power 4. So, the first logarithm will be written in the form logarithm base 3 to power 4 of 3. For the second logarithm, we will use the properties that we already used. The square root of 5 we will write as 5 to power 1 half, while 1 over 5 we will write as 5 to power minus 1. For the third logarithm, 2.5, we will write it as 5 divided by 2, while 0.4 we will write it as 2 divided by 5. Next, by using the following property of logarithm, for the first two logarithms, we will get the following form of the exercise. 1 over 4 logarithm base 3 of 3 minus 2 multiplied by minus 1 logarithm base 5 of 5 plus, and here is a small trick. We can inverse 2 over the 5 in the form 5 over the 2, but we must write it to power minus 1. So the third logarithm will be written logarithm base 5 over the 2 from 5 over 2 to power minus 1. And here, in the first two logarithms, we have the same base and the same argument. And according to this property, the answer of logarithm is 1. So, the exercise will be written in the following form. 1 over 4 plus 2 plus minus 1 logarithm base 5 over 2 from 5 over 2, which is equal to 1/3 plus 2 minus 1, and in final we get 5 over 4. That's nice. Next exercise. 49 raised to power 1 plus logarithm base 7 of 2. Interesting exercise. If you analyze attentively the exponent of this power, you see that you have a natural number added to a logarithm. According to this property, number 1 can be written in form of logarithm in whatever base you want. And here, because we have logarithm base 7, we will write 1 as logarithm base 7 of 7. And we will get the following: 49 to power logarithm base 7 of 7 plus logarithm base 7 of 2. Next, because we have the sum of two logarithms, we have the same base, and using the following property, which we already used today, we'll get the following form for the exercise: 49 raised to the power logarithm base 7 of 7 multiplied by 2, which is equal to 49 raised to the power 7 of 14. Next, we can see that 49 and 7 somehow are connected, these numbers, because 49 is 7 raised to power 2. So we get 7 to power 2 logarithm base 7 of 14. Next, by using the property that we already used this today a lot of time, we can bring 2 as the exponent to power 14. And we will get 7 to power logarithm base 7 of 14 to power 2, which is equal to 7 to power logarithm base 7 of 196. Next, by using the property which is written here, we see that the answer of this exercise will be, yes, 196. Let's continue. Find the following without using a calculator. Log of 25 to power logarithm in base 5 of 6 plus 3 to power logarithm in base the square root of 3 to power 8. So, let's analyze attentive the argument of this logarithm. We have 25 to power logarithm base 5 of 6 plus 3 to power logarithm base square root of 3 of 8. But if we analyze attentive, we can see that 25, we can write it as 5 to power 2, while the square root of 3, we will write it in the form 3 to power 1 divided by 2. Next, by using this property, and using this property for the second logarithm, the exercise will be written in the form log of 5 to power logarithm base 5 of 6 to power 2 plus 3 to power 2 logarithm base 3 of 8, or in the form logarithm of 5 to power logarithm base 5 of 36 plus, so 2 we brought it as the exponent to 8, and we have 3 to power logarithm base 3 of 8 or raised to power 2. Next, for the first expression, by using this property, we had the following: logarithm of 36 plus 3 to power logarithm base 3 of 64. Next, for the second expression, using the same property, we will get the following: logarithm of 36 plus 64, which in fact is logarithm of 100. But remember, what does logarithm mean? If the base is not written, we assume it is base 10. And we can see that 10 and 100 are somehow connected, because 100 is 10 to power 2. So we have logarithm in base 10 of 10 raised to power 2, which in fact is 2 logarithm base 10 of 10. Here we use this property. And next, by using the property that logarithm in base 10 of 10 is equal to 1, we get that the final answer is 2 multiplied by 1, which is 2. Next one. 3 multiplied by natural logarithm of 3 plus natural logarithm of 12 over this expression divided to logarithm in base e, or the natural logarithm of 2, plus 2 natural logarithm of 3. So, in this exercise, we see that we can apply for these two logarithms the following property, and the exercise will have the following form. Natural logarithm of 3 to power 3 plus natural logarithm of 12, both these logarithms divided to natural logarithm of 2 plus natural logarithm of 3 to power 2, which in fact is natural logarithm of 27 plus natural logarithm of 12 over natural logarithm of 2 plus natural logarithm of 9. Next, for these two expressions, using this property, we will have the following. Natural logarithm of 27 multiplied by 12, which is natural logarithm of 324, over natural logarithm of 2 multiplied by 9, which is natural logarithm of 18. And because 324 is equal to 18 to power 2, by using this property, we can bring 2 in front of the logarithm, and we get the following: 2 natural logarithm of 18 of the natural logarithm of 18, which in fact the answer is 2. Great! So, thank you very much for your attention, and we really hope that this material was very easy for you, and you understand that difficult mathematics in the math world is a very easy one. Next, please like this video, share this video with your friends, and subscribe to our channel. And one more, please help us to make your math life easier. Write in the comment which mathematical theme you think is very difficult for you, and we will make it a very easy one. Thank you one more time for your attention, and good luck to you.